KP multiple choice questions, 16 mark scheme included. Let's go. So the equation for the reaction of sulfur dioxide was a mole fraction of sulfur trioxide. So first thing we're gonna have to do, create a table, right, of the products and the reactants. I initial moles, C change in moles, E equilibrium moles. Initially we have 2 moles of sulfur dioxide, 2 moles of oxygen, 0 moles of sulfur trioxide. Total amount at equilibrium is that. So we're gonna have minus x plus x and that is equal to 3.4. 2 minus x plus 2 minus x plus x, and that's equal to 3.40. Can you guys even hear me? Yeah, you can. 3.40 minus x plus minus x minus 2x plus x minus x. So I get x equals 0.60. Was a mole fraction of sulfur trioxide, that's going to be 0.6. No, it's not, because we've got 2 moles of sulfur trioxide, so it's going to be 0.60 times by 2 divided by 3.40. So 1.20 divided 0.60 times by 2 divided by 3.40, 0.353. Therefore the answer is B. I'm just going to go like that. Next one, question 2. Which change increases the equilibrium yield of ammonia but has no effect on the value of equilibrium constant Kp? Catalysts have no effect on equilibrium yield and ammonia. Increased partial pressure of nitrogen. Increased partial pressure of nitrogen. Then yeah, it would increase the equilibrium yield of ammonia. Decrease the pressure, forward reaction is exothermic. Decrease the pressure is going to shift to exothermic direction, so that will. It's between B and C. Oh, but it says no effect on the value of Kp. Well, a decrease in the temperature will, because only temperature can affect the value of Kp. Therefore, the answer must be B. There's 2 conditions, so the answer is B. Just because of that, no effect on Kp must be B. Question 3. Mole fraction of butane in a mixture of butane and oxygen with the minimum amount of oxygen required for complete combustion. Mole fraction of butane is what? Number of moles of butane, 1 over the total number of moles, butane and oxygen, 6.5 plus 1. No 0.133. Question 4. Which statement about Kp is correct for this reaction in the gas phase? The value of Kp is independent of pressure. Okay, there's a lot of these. Value of Kp increases as pressure increases. That's false. Pressure has no effect on the value of Kp. The value of Kp is independent of pressure. The value of Kp increases as temperature increases. I know the forward reaction is exothermic because its delta H is negative. So if I increase the temperature, it's going to shift to the endothermic direction, this direction, and therefore we're going to have more reactants. So therefore the value of Kp would actually decrease because products, would decrease. So I'm left with A and D. The value of Kp is independent of temperature. No, the Kp is dependent of temperature. The answer is A. Question 5. The mole fraction of hydrogen in the equilibrium mixture is. I've got the number of moles, and at equilibrium I already have the equilibrium moles. At equilibrium temperatures, that total pressure, that number of moles are present are, yeah, so all I have to do is the mole fraction of hydrogen, the moles of hydrogen, 0.320, but I need to times it by 2 since there's 2 moles in the chemical equation, divided by 0.160 plus 0.320 plus 0.180, just the total number of moles. I get 0.970. For the answer is D. Question 6. Which of the following statements about a catalyst is / are true? It speeds up the forward reaction and slows down the reverse reaction. That is false. It speeds up the forward reaction and reverse reaction equally. Increases the proportion of molecules with higher energies. Increases the proportion of molecules with higher energies. No, it increases the proportion of molecules with lower energies, because a catalyst definition is a substance that provides an alternative pathway with a lower activation energy. Homogeneous catalyst usually acts in a solid state. I'm not sure about that, but I know for the fourth one is correct. It does not alter the value of the equilibrium constant. That is true. Question 7. Which of the following statements applies to this equilibrium? The value of Kp increases as if the temperature is raised. The value of Kp increases, pressure is raised. No, only temperature can affect the value of Kp. The yield of methanol decreases if temperature is lowered. That. So I know that entropy of formation, entropy of products minus entropy of reactants is negative 91. Delta H is negative 91. That's not really important. The negative is really important. So that tells me the forward reaction is exothermic. So if the temperature is raised, equilibrium is going to shift to the endothermic direction to oppose the increase in temperature. Therefore, we're going to have more reactants. Therefore, the value of Kp would decrease. So it's not that. It's not A or B. The yield of methanol decreases if temperature is lowered. Temperature is lowered. Equilibrium is going to shift to the exothermic direction to oppose the decreased temperature, aka increase in temperature. So it's going to shift to the exothermic direction. Therefore, methanol would increase. That's false. The yield of methanol decreases if the pressure is lowered. If the pressure is lowered, equilibrium is going to try to increase the pressure. Therefore, it's going to shift to the side with more moles of gas, which is the left hand side. We only got 3 here compared to 1. Therefore, the yield of methanol would decrease. Question 8. With pressures expressed in MPa units, the value of the equilibrium constant Kp under these conditions is. I'm given the equilibrium moles. I'm given the total pressure. So I'd probably want to find out the mole fraction. Find out the mole fraction. So let's do that. Let's find out the mole fraction of carbon monoxide. 0.160 divided by 0.320 plus 0.160 plus 0.180. I get 8 over 33. That's for carbon monoxide. 0.320 divided by 0.320 plus 0.160 plus 0.180. But I've got 2 moles of hydrogen, so I need to times it by 2. Actually, no, I don't. If I times it by 2, I get 32 out of 33 for hydrogen. But I just want it for, yeah, all I want it for hydrogen, and then I'll square it. Yeah, that's the thing. I forgot about that. So it's 16 out of 33, and methanol, it's going to be 3 out of 11. And to double check, you know, your values are good, just add them all up. If I add all these values up, should get 1, which I do get. Now I want Kp. Kp is going to be partial pressure of products of the reactants, and obviously for hydrogen it's going to be squared because there's 2 moles of it. So all I need to do now is find out the partial pressures by timesing it by the total pressure. And then I'm pretty sure now all I do is just substitute into my calculator. So 3 out of 11 times by 1.70 divided by 8 out of 33 times by 1.70 times by 16 out of 33 times by 1.70, but that is squared. There's 2 moles of it, and you should get 1.66. That was a difficult one marker. Question 9. Possible units for the equilibrium constant Kp for this reaction are, well, the units is just going to be total pressure MPa. It's just going to be product, so let's say MPa divided by MPa, that's 1, and then 2 MPa, so MPa cubed. So that will give me 1 over MPa squared, and that is the same as MPa to the power minus 2. That's if the units were MPa. It says possible units. So I know that my answer's got to be to the power minus 2. There we go, Kpa to the power minus 2. MPa, no, b to the power minus 1. Kpa, no, and no units, no. Question 10. Temperature in the equilibrium vessel is. So I'm given a lot of values, and I want to know the temperature in the equilibrium vessel. And I know that equilibrium vessel can do this much moles of that. So I'm not really sure what to do for this one. Do I find out K? Because obviously I can tell that, yeah, delta H is negative, and so if Kp increases, that means the temperature is lowered, and I guess I could do trial elimination. I'm not really sure for this one. I'm gonna leave this one for another separate video. Don't want to waste time just when I'm not fully sure on it. In question 11, possible units for the equilibrium constant Kp include. Well, I've got could do kPa squared, 2 moles of that, divided by kPa squared times by kPa. So that is going to be, well, that's going to cancel out. I'm going to be left with 1 over kPa, therefore kPa to the power minus 1, or anything to the power minus 1. In this case, MPa to the power minus 1. Question 12. The value of Kp is. So first thing I would do is just find out the mole fractions. 7 over 20 SO2 1 over 4 O2 2 over 5. Then what I need to do is times by the total pressure and partial pressures and include the moles, so square some cases. So products 7 over 20 times by 540 squared divided by 1 over 4 times by 540 squared times by 2 over 5 times by 540 squared. No, that's not squared. I get 9.07 times by 10 to the power minus 3, and therefore the answer is 9.07. Because the reason I got 10 by 10 to the power minus 3 because I didn't convert kilopascals to MPa. But I don't really need to, because as long as I get like 9.07, yeah, I don't really need to convert into the units. Because I'm going to get 9.07 either way. It's just, is it 10 by 10 to the power minus 3, or is it going to be 9.07 if I convert it correctly? Also because I forgot how to, I don't know how to convert between kilopascals to MPa, but I didn't need to. Question 13. Mole fraction of SO3 in this equilibrium mixture is. Equilibrium occurs in that equilibrium vessel contains that much. All it's going to be 0.0700 divided by 0.0700 plus 0.0500 plus 0.0800. However, there's 2 moles of SO3, so we need to times it by 2. Times by 2. I feel like that's the main trick. If you do that, it just wants SO3. So we actually leave it as 0.0700. Therefore we get 0.350. Question 14. Temperature is decreased. Mixture is out to reach new equilibrium, which is greater for new equilibrium than for original equilibrium. Well, delta H is negative, so I can see that clearly there. So the forward reaction is exothermic. backwards reaction is endothermic. So if I decrease the temperature, it's going to shift to the exothermic direction. So that is going to increase. The mole fraction of carbon monoxide, no. The partial pressure of chlorine, no. The total pressure of the mixture, no. The value of the equilibrium constant Kp, yes, because I'm going to have more products divided by reactants, so therefore I'm going to get a bigger value of Kp. And remember, because it's temperature, only temperature can affect value of Kp, and we are changing temperature, therefore it would. Question 15, which of the following statements is not correct? Is false, I like to say. Value of Kp changes when temperature changes. That's true. Activation energy decreases when the temperature is increased. Entropy change is more positive when the water is liquid rather than gaseous. Activation energy decreases when temperatures increase. Temperatures increase. Yeah, the answer is going to be C. Entropy change is more positive when the water is liquid rather than. Actually, no. The answer is going to be B. Activation energy decreases when temperatures increase. No. Question 16. Which change would alter the value of equilibrium constant Kp for this reaction? Increase total pressure of the system. Increase the concentration of sulfur trioxide. Increasing the concentration of sulfur dioxide. Increasing the temperature. It doesn't tell me if Ford's reaction is exothermic or not. Increase total pressure system. No. Increase the concentration of sulfur trioxide. Answer is going to be D. And now it's going to take a while to mark. I will take screen pictures on my phone, and then we don't have to keep scrolling back and forth. Perfect. So question 1. The answer was B. Correct. Question 2. The answer was B. Perfect. Question 3. The answer was A. Perfect. Question 4. The answer was A. Question 5. The answer was B. Which actually makes sense because it says the mole fraction of hydrogen, not 2H2. So if I do 0.320 divided by 0.320 plus 0.160 plus 0.180, I will get 0.485. So yeah, that makes complete sense. Fell for the trap. Question 6, D. Question 7, D. Question 8, B. Question 9, D. Perfect. Question 10, D, but I didn't know question 10, so yeah, skip that one. Question 11, C. Question 12, C. Question 13, B. Question 14, D. Question 15, B. And question 16, D. Perfect. So I only got question 5 wrong, and also I skipped question 10. Not bad.